All right, great. Hello, good morning, good afternoon, good evening, based on the time zone that you're joining in. My name is Siddhant, and I'm super excited to welcome you all to the first session of APAC training series. This is for the first time that we are doing a training series, a workshop, an online one in the APAC time zone, and I'm super excited to talk to all of you. And more than me, we have an amazing speaker who is going to talk to you and share how to get started with Neo4j. But before we do, a quick introduction about Neo4j. One second. Right. I'm assuming that people already know about Neo4j, but for those who don't know about Neo4j, well, Neo4j has a lot of Indian connection, which I'm really proud of because the idea was conceived on a flight to Mumbai. It was way back in 2007 when the company and the product started and started as an open source community edition and then pivoted to a cloud source enterprise edition as well. So we're kind of in an open core model at the moment. You can use us on your 4J desktop or the Docker image as well. We are available on Google Cloud, Azure, and AWS. We launched the Neo4j version 5 last year in November 2022. Well, that's a quick brief on Neo4j, what Neo4j is. I'm not going to bore you all with the background of Neo4j. I'll leave it for you to find it on Google, on our website, neo4j.com. But yes, I have something for you. Is this T-shirt, this awesome T-shirt, this Neo4j T-shirt. If you want to win this T-shirt, you have to do something for me, which is a simple tweet about how excited you are for this session. Make sure you tag me. That's my Twitter handle and Neo4j handle. Use this hashtag graphs are everywhere. Well, we say, and you'll be hearing all the Neo4j employees nodes, as we call ourselves, saying that graphs are everywhere. Well, graphs are everywhere, and we want to make sure that graphs become democratized in the future. With this, I would like to invite the first speaker who is going to talk to you about what Neo4j is, how to get started with Neo4j. So I have my dear friend Chintan. Let me bring him to the stream. Yes, Chintan, how are you doing?
Hey Sid, I'm doing good. How are you?
Doing good. Excited for the session today?
Great, yeah.
Great. Cool. So I'll let Chintan do the talking and also introduce himself. I'm not going to do the introductions for Chintan because he wanted to do it himself. Uh, Chintan, before we bring your slides on screen, let me do this. I wanted to do this for a long time.
Yeah.
It's action, and you can go on.
Okay. So thank you so much, Sid, for setting this up and inviting me to talk about the Neo4j introduction session. And I mean, I'm really excited that we are doing this first time for APAC. And so basically, I would say good morning, everyone, or good afternoon, good evening, if you are in other time zones. My name is Chintan Desai, and I am in Pune, India. I am a software engineer. and I'm currently working with Nice Systems based in Pune. And I'm here because of my love for graphs and Neo4j graph database. So I spent a good amount of time as a consulting engineer with Neo4j, and now trying to contribute my part to the community. And thanks to Sid that and the other community members who are giving me these opportunities to contribute to my part and talk to the members who are willing to learn more about Neo4j. So today, we'll go through the introduction part of Neo4j. We will cover the basics of graph and graph database problems, and then we'll discuss about graph database and have an introduction of Neo4j property graph database, and we'll also do some hands-on uh, and talk about uh, how you can move ahead in your graph database journey. So what we'll learn, so as I said, we'll primarily have below areas to explore. We'll talk first about graph databases in general, why graphs are amazing, why they are really great representation of the real world problems, the real world scenarios, and where can we use graphs. So what are the scenarios and use cases for using graphs, right? So looking at and then we'll look a little bit at the property graph model and a quick introduction of Cipher, that's the query language for Neo4j graph database. And then we'll actually want to do some hands-on. So all of you can code along with me here, because we will use the Neo4j Aura. So in Neo4j Aura, you can easily set up the Neo4j graph database and access it within a few clicks. And it should be pretty straightforward for you to set up. I think we have some instructions sent over to you at in your registration process, so that you might have already set up Neo4j Aura. If not, or if you have missed, I'll cover the steps in my presentation, and then we'll explore an example database that is a movies database with Neo4j browser, and we'll execute some Cipher queries, and we'll visualize the results. And the Neo4 and we'll go through the Neo4j importer tool. So Neo4j data importer is another useful tool that we'll go through. And at the end, I'll give you some demonstration of the another tool that we have with Neo4j. So that is Neo4j Bloom, that is for graphical representation and visualization for the graph. So moving ahead, as I said, before we start with the actual content, let's go over to the Neo4j Aura website. And Neo4j Aura database is basically a database as a service that can be availed to run Neo4j graph database in a matter of few clicks. And you can set and run your database without any hassle of installation and administration of the database. So what you have to do for installing Aura? So first, you will have to go to the Neo4j Aura console. So I have mentioned these links in the deck: neo4j.dev.neo4j.com/aura login or console.neo4j.io, and then register yourself and choose Aura, and then click on the new instance, and then choose the movies database option. So let me go through the next slide. So basically, when you go to Neo4j Aura login or console Neo4j.io, you will see a link where you can register and then go to the Aura DB. Once you go to the Aura DB, once you are logged in, you will see a screen like this. So I'll wait for like 30 seconds or 1 minute time, so that you guys can register yourself. It's a matter of a few clicks and filling out a few fields like user, your email ID and your password, and then you register. And once you register and log on, you are on this page where you see this button. Okay, so I assume most of you are already registered and logged in, and someone who are not already registered, they must have registered themselves by now. So if you are seeing this screen, you need to click on a new instance. When you click on new instance, you will see a page something like this, where there are some preloaded databases like movies, graph based recommendations, cybersecurity, Stack Overflow, and an empty database instance where you don't have any data. So today we are going to have some hands-on on this movies database. So I would say click on the create button, when you hover on these movies, you will see a create button. So click on the create button. That will basically create an instance of Neo4j database with preloaded movies database for you. When you click on these movies, you will see a pop-up like this, where you will get a generated password for your Neo4j database instance. So you can copy this password and save it somewhere, or you can click on the download button. So I would recommend you click on the download button. This will download the credentials of the Neo4j instance that is created for you, and the URL for the instance. So for example, in other databases like SQL Server or MySQL, you have connection string to connect to your database. So similar to this, you have a URL using which you connect to the Neo4j database instance. So you will get those details as a part of the downloaded file. And when you do this, when you create this instance, this is totally free, and this is just for your learning, and basically try out the Neo4j database with some of your example applications or exploring the Neo4j database. Okay, so once you click on this button, it will launch, it will go back to the instances page, and it will take some time to keep your database up and running. It will take a couple of minutes. So meanwhile, we'll talk about some fundamentals and basics of what is graph and what are the graph databases. Okay, so I'll move next. So what is a graph? So is this the thing on the left or thing on the right? Okay, actually what we call graph is the thing on the left. Okay, so on the left you see a network of connected entities or connected nodes. On the right side, many times people call it as a graph, but we prefer to say it is a diagram or a chart to make distinction. Okay, so for us, the graph and the network are what we are talking about, this diagram versus this chart. So this is what we call as graph. Okay, moving on to the next one. So graph is basically a collection of discrete entities and some relationships between those entities. Graphs are a useful way, or a useful way to model the data for the purposes of mathematical or statistical analysis. Okay, so they have been around for a long time. The first use of graph database was done in long back in 1735. So it was done by a mathematician in Russia. So yeah, as I said, it's a set of discrete entities and relationships with other entities. Okay, so long back in 1735, a mathematician from Russia used the graph theory to solve a problem which is called the seven bridges problem of Königsberg. So there is a city in Russia which is now called as Kaliningrad, but before some time, I mean, in the 1700s, it was called as Königsberg. And there was a typical problem where basically there were some land masses, and there was a river passing through, and there were two islands which were basically generated because of the river flowing through, and there were some areas around those islands, and there were seven bridges to cross the river and reach from one landmass to another landmass. Okay, so the problem was, is there any possible route through which we can cross every bridge at least once and only once? Okay, so you start from here and you cross all the bridge at least once and also only once, and then you complete your journey. Okay, so for representing this problem, a mathematician called Leonard Euler, he used graph theory. Okay, so he represented the problem like this: these are the two land masses, and these are the islands created by this river, and these are the areas which are on the sides of the river. So he represented the problem like this. So he represented the land masses using nodes, and the bridges connecting to those land masses he represented using the relationships. And that's how he proved that there's actually no way using which you cross all the bridges only once and then visit all the land masses. Okay, so for this he uses the graph theory. That was the first time the graph theory was used, and after that the graph came into picture. It was used at many places. So graphs are basically everywhere. So if you search on Google, you go to the Google search and you search for any problem, and many of the times you will see that a graph based representation will appear. Okay, many time we also, if we have a problem and we want to have some solution for the problem, so we used to do the connectivity and flow diagram for the problem, and then we need to we used to arrive on the conclusion, right? So that is basically how graphs are useful to us. Okay, now talking more about why graphs are amazing and what are some real world problems of impact using graph. Okay, so always, if you think about anything in the world, there's no nothing like a disconnected pieces of information. Everything in the world you can think of is connected. We are connected with our relatives, we are connected with our friends, our friends are connected with some of their friends. Okay, so everywhere there is a connection. If you think about historical events, that something happened in past, and because of that event some other event happened, then there's a chain of event that happened. Okay, so everything is connected. So the first event, because of which the other events happen, and then there was a chain of event due to which we are seeing something in the world right now. There's a change happened in the world because of some events in the past, so that is all connected. Okay, if you think about like biology, so in biology you have some molecules, and for example you have a water molecule which is comprised of H2O, so two hydrogen units and one oxygen unit, so they are connected and they form the water molecule. Okay, so this is how it is connected. And there are so many things. I mean, you can talk about the transport networks, that you can take a route from one city to another city, and you can go via these all cities, so they are connected, and what is the shortest paths to reach from one city to another city. So there are many scenarios in which you can use a graph database to represent your problem and come out to a conclusion that what is the effective solution for you. Okay, so imagine that we have the same. So we draw something on a paper and we connect some pieces and come to a solution using those pieces. Okay, so imagine you can save your data in a database in a similar fashion, the way you are thinking. Okay, so that is what graph database is. So if you come up with a problem and you draw some solution on a paper using some entities connected to each other, and then basically some flow or some connectivity between different entities, and then you try to conclude your solution. So imagine that in the same way you are having a feature to save these data and relationships in the database. So that is what a graph database is all about. Talking about some more use cases of graph database, so you might have heard about the Panama Papers, which came out in 2016, right? It basically exposed many high net worth individuals and their involvement in some fishy practices. Okay, that people from some countries, they are having some companies registered in some tax havens, where there is no taxation, and they are doing some business using those shadow companies and all. Okay, so when the when the ICIJ team began their investigation, they actually used a graph database to link those individuals and those companies and the connections between them, and how they are making these fishy practices to basically to save their taxes, to have some fishy practices in place. Okay, so they used a graph data model. So this is the high level graph data model that was used for the Panama Papers research. So you see, there are different entities. Like there's an entity, and entity is basically a company, and there's an intermediary, and then company has an address, the company has an officer, and then it is also officer of something else, and they are connected with each other using different relationships, like shareholder of, officer of, intermediary of, etc. Okay, so this is how they use graph database to come to the conclusion, basically have their research and further revelations. Okay, then came the Panama paper, then came some news, and after the Panama Papers, basically it created a lot of moments, right? uh, it was in news for a long time. Then came the The Paradise Papers, it came in 2017. It was a similar kind of a research, and it was also carried out using graph database. Then the Pandora Papers in 2021, it was also carried out using graph database. Then unfortunately, we had a bad time. A couple of years we were hit with COVID. So at time of COVID, there were a lot of projects which were carried out using graph database. Like, you can think of the COVID patients or symptomatic persons contact tracing, right? So if I am a COVID patient and I got in contact with a few more people, they got in contact with a few more people, so there's a connection that I got in contact with someone, and that someone got in contact with some other person. So that is a contact tracing. So that's a very clear example of graph database, right? That's how you trace the contact history of a person and find out, okay, how many people might be infected because this person came in contact with them. Then there were also some research like, uh, the COVID happened because of some virus. It was COVID-2 virus, and basically there were many research that happened on the sequences of the virus, and that there also the graph database was used. Okay, so moving on, what makes for a good problem to solve for, what makes a good graph problem to solve for? So how do you conclude that? So many of us are basically coming from the relational database world. Some people are using the NoSQL databases or document databases like Mongo and all. So how do you arrive at a conclusion that for my problem, is graph database applicable or not? Is my problem a good problem for graph database or not? Okay, so there are a bunch of good graph use cases. So whenever this I would say, whenever relationships, context, or topology of entities are important than the entities themselves, okay, and you want to use relationships or the context or topology of those entities to analyze the data, to come to some conclusion using the relationships, okay, at that time considering a graph database makes more sense. Okay, so for example, the thing that you are seeing on my screen is a customer who is having name Lisa buys a product. She buys a t-shirt which is having a red color, small in size, and it is part of a category called t-shirt. So t-shirt is a category, and this is a product belonging to that category. Lisa buys a product, and then there's one more person called Jane, also buys the product which is of some other type, like other color, other size, other SKU, stock keeping unit, and that is also falling into the category. Okay, so that is how you visualize or basically demonstrate your entities and their relationships using a graph database. So if you want to like generate something like, hey, if two people are buying a product from the same category, so this category products are in trend, and I want to recommend other people that, hey, you can buy products from this category. So you want to build some recommendations engine using a use case like this, then yeah, graph database is of use. You can use graph database effectively, and you can easily achieve your recommendations engine use case using graph database. You can think of some other database to achieve this. So in case of relational database, you will have tables. You will have a table where you save all the customers in different rows. You will save the customers, and there's another table for products, and there's another table for category. Okay, and then there are basically foreign keys between customer, and there's an order table which has the orders and where you save the customer ID and the product ID, and then there's a table to map the product with the categories and all. So they are merely reference, they are merely foreign keys. So you cannot visualize and easily conclude and solve your problem using the RDBMS, but instead you use this kind of a model. You can easily come to conclusion, you can easily solve your recommendations engine problem using this use case. Okay. Also another case like the most obvious thing like social network. So for example, LinkedIn. In LinkedIn, I am connected to some people, and those people are connected to some other people. So LinkedIn gives me a suggestion that, hey, you might be knowing this person, right? So that is a recommendation using the representation of entities and the relationships between them. I am a node which is connected to some other entity which is another node. I am linked to that person. That is my first connection. That connection is connected to some other connection. Okay, so that is one more use case. There are many use cases like bill of materials. In the bill of materials, basically you have uh, some component which uses some other raw materials, so they are connected to those raw materials, and in order to produce those raw materials you need some other small parts. Okay, so that's how you basically represent those entities. And there can be some more cases like uh, transports and uh, s- supply chain and all, where you can effectively use graph database instead of the traditional relationship data I mean traditional relationship based database, or uh, the document based database. Okay, coming to the second scenario. So you see the hierarchy here. So hierarchy is also one of the interesting use cases of the graph database. So you see Jane is an employee, and Jason is basically reporting to Jane. So Jane manages Jason, and Jason manages another person whose name is John. Okay, and Jane also manages Joe. So this is how you represent the hierarchy, and it is effectively represented in graph database. Coming to the another scenario. So you see one organization whose name is Pencils and are used, and then it sells product pencil. And there's a stationery, so it can be a shop or it can be a mall who sells all the stationery items, and it buys the product pencil from this organization. So this is how it is represented, that this is organization is a node, this is a node product, and this node is our organization, this sells product and this buys the product from it. Okay, and then this organization buys the product wood, which it uses to basically manufacture pencils. And this we sell wood kind of organization, it sells the product wood. So this is how you represent your supply chain. And bill of materials and network management, routing, these kind of use cases are also similarly visualized and represented in graph database. Okay, there's one more scenario which I'll quickly discuss. That you see this is basically a diagram of the uh, transport system, where basically you have some towns as stops, and you take different routes to start from one stop to and reach to another town. So you take this route to reach from London to Edinburgh. Okay, so this is how it is represented. And there are a lot of use cases like cyber security, network management, identity and access management. So possibilities are almost endless. The most challenging thing for a graph database is that you can do so many things using a graph database, and it is really hard to pinpoint that, hey, is this the killer use case for a graph database or not. So as I said, there are many useful examples, but if you want to make out if graph database is useful for you, you just think about, is relationships, context or hierarchy is important to me than just entities. Okay, so in that case you can conclude, you can zero on the graph database. Okay, yeah, so moving on to discuss more on the Neo4j property graph model. So in a property graph model, when we say a property graph model, so in property graph model there are objects in the graph, and there are properties on those objects. So when I say graph, as I said, there are nodes and there are relationships. Okay, so in Neo4j, uh, there are nodes, there are relationships, and we have properties on nodes as well as we have properties on relationships. Okay, so talking about nodes, so nodes are basically, some people call it a vertex or vertices. Okay, so they are basic building blocks of a graph. They are used to represent objects of entities in interest of a given domain, right? So for example, if I want to show something like a social network, then in case in social network everybody is a person, right? So we can represent a person as a node, and a node can be labeled uh, to form groups of similar entities. Okay, so basically for example, in LinkedIn social network, there are person nodes, and the persons are working for some organizations. Okay, so you can call a person as an entity, and then you can call an organization as a different entity. So you create a node type, and you label that node as a person. You create one more node type and you label that node as an organization. And the node type of label, the person type of node, basically it has some properties like name, age, and Twitter handle, and some other properties like date of birth or something. And the organization types of nodes, which are like companies, they can have properties like, hey, what's the name of the company, what's the address of the company, what's the headquarter of the company, who's the CEO, probably name of CEO or something, in what year the company was founded and all. So these kind of properties can go on the organization label. Okay, so sorry, nodes can basically have the label and properties. Moving on to the next building block. So relationships are basically another important block. And I would say relationships are the first class citizens in Neo4j. So relationships are basically edges, and they are used to connect nodes. So here you can see a person node, it is connected to another node. So for example, here we are taking the vehicle or a car. So we have labeled this node as a vehicle and car, and person owns a car since 2011. So in case of property, in case of relationships, they have a type. So in case of property, this property, we have a type that is owns, and it has a direction. So it is going from person to vehicle. So the person owns vehicle. So direction and type both are important. And property also, relationships also have properties on top of them. So here you can see that since 2011 the person is owning this car, and the person has some properties, the car has some properties, and the relationship, the owns, also has some properties. Okay. So this is how relationships are represented. Now coming to properties, as I already described of properties in nodes and relationships, so they basically add more value, or I would say color, to the graph. So every entity in graph has its own properties. Every relationship has its own properties, and they are represented as key value pairs. So here you can see the key is since and the value is 2011. So it is, you can relate it more like a JSON type of a format, where you have the name of the property and you have the value of the property. So this is how the properties are represented. Okay, and meanwhile, when I'm going further, if you have any questions, I hope Sid has enabled the chat, so you can drop your questions in the chat, and Sid, you can just give a heads up to me if there are questions. We can answer those questions before moving further.
I'll keep you posted.
Okay, so more on the property graph model. So as we discussed, nodes having labels, relationships having types, and then all of them have their properties. Okay. Now moving ahead, so we talked about how we store oh, sorry, how we store our objects in graph. So storing in the form of nodes and other nodes and relationships connecting to them. Now you must be thinking, how do we access this data, right? We store the data in graph, but basically how do we store the data? So first of all, yeah, even before accessing, how do we store this data? So you got a Neo4j graph database, and you got an idea that, hey, I have to store nodes and relationships, and I have to decorate those nodes and relationships with some properties. But how do I basically store this information and query this information out? Okay, so we have in Neo4j, we have something called Cipher. So Cipher is basically a query language for Neo4j, for accessing the Neo4j graph database and making changes to the Neo4j graph database. Now you must be thinking that, hey, why should I learn a new language? And I mean, uh, I am already learning a lot of languages for other database. We have some other languages for databases like Node and all. We have some schemas and everything. So am I learning a new language now? Do I learn a new language now? So don't get overwhelmed when I say you need to learn a new language. So Cipher is a very easy query language. It's a pattern matching based query language, and it's declarative and expressive. So I'll talk more on Cipher in our next slides, but you can consider that Cipher is one of the most easiest query language that I came across in my programming experience. Okay, so it is declarative, it is expressive, it uses ASCII art. It is built to be easily understood by both the development people and non-development people, like business users, business analysts, data scientists, etc. Okay, and so this graph database category is new in the world, right? So it has been there since last few years, but now it is trending more like other databases. Okay, so like the other databases, so talking about the relational databases like SQL Server, Oracle, MySQL, Postgres, so it has a standard query language for them, right? So it has a SQL query language, so it's a standard. So similar to this, uh, there is a GQL, graph query language, standard language which is in the making, and it will be a standard language for graphs. And Neo4j Cipher is contributing to GQL in a very big way. So the way you write queries in Cipher, it will be contributing in big way to the GQL. So when there will be GQL standard, if you have knowledge of Cipher, so it will be very easy for you to move from Cipher to GQL. Okay, so this is what Cipher is. Now there is a cheat sheet that I have created, and I'll share this deck with Sid, and Sid can pass it over to you guys. So there's a cheat sheet that you can keep handy while you are basically trying out some Cipher queries. So I have mentioned some generic things like in order to show nodes, you have to use this kind of parenthesis, and in relationships, you can use this kind of patterns, and you can use a node reference. You can how do you use a label, how do you use relationship type, how do you basically add property to a node, property to a relationship, and then how do you use a node with a variable. Okay, so in here you see that we are declaring a person, it is declared with a label, and there's a property. But here we are doing the same thing, but we are adding a variable for it. Okay, similar to this, we have a variable for relationship. So this is a cheat sheet which will come handy. There is also a Cipher cheat sheet available on the Neo4j website. So you can see the link over here, dev.neo4j.com/refcard. And you can keep this page open while you are doing some Cipher queries and working on your Neo4j use case. This will come handy. This has a lot of easy navigation, and it has details of all the things that come handy while you are basically querying your Neo4j database. So for example, in SQL, you have select queries, and you have joins, and you have unions, and you have aggregation and all. So similarly in Cipher, you have simple clauses, you have uh, uh, some conditions, you have some delete, remove, merge kind of statements, and also some aggregations or all. So this page gives you all the information in a handy way to you. Okay, now let's get started with some hands-on and use the graph applications. Okay, so as I discussed in the beginning, we set up the Neo4j graph database instance on the Neo4j Aura. So it must be up and running by now. So let me move to my browser. So if you have set up a Neo4j instance, you must be seeing an instance like this running on your machine, on your browser. And here you see explore, query, and import, three buttons. Okay, and you must be seeing instance one here. So what you can do is you can just click on these three dots, you can go to rename, and you can just name your database as movies if you want to just correct the name of your instance. I have just renamed it from instance one to movies. Okay, now moving on to the next one. So here you see a screen like this. Now you rename it, and you click on, so I'm back to my browser. So you click on the query button here, and it will take you to the Neo4j browser. So Neo4j browser is basically, you can consider that it's the same tool like we have the SQL Server Management Studio, or for Postgres we have PG Admin. Okay, in case of Oracle we have tools like Toad or something. So it's similar kind of a management studio for Neo4j. So when you reach this browser, you will have to enter the username and password. So if you remember, I asked you to download the passwords file, credentials file, when you created your Neo4j instance. So the file has the credentials information. So you get your password from there and you paste it and you just click on connect, and it will connect you to the Neo4j instance in this Neo4j Aura database as a service. So I just connected my Neo4j instance. Okay. Uh, Moving back to my presentation. So we are on the browser, and yeah, so now we have some hands-on. We'll execute some queries on the Neo4j instance that we created, and I have a link in here which I will, let me see if I can put it in the chat. I'll pass it on to Sid so he can basically put it in the chat. So Sid, I'm passing this link to you. You can just put it in the chat so that everybody can follow the steps that I'm following.
Sure, just 1 second.
Okay. So now I'll go to my browser again. I have this workshop steps, the link that I shared in the chat, open here. And here you see the Neo4j browser. So in Neo4j browser, you see the database information. So here, like in SQL, we have we can have different databases, and Neo4j also we can have different databases. By default, there's a system database that you don't touch generally. There's a default Neo4j database. If you want to create a new database, you can create a new database using different commands. I'll not cover it now, but by default, the Neo4j database is selected. And since we selected the preloaded movies database, so here you see some nodes and relationships already populated. So there are 179 nodes and 259 relationships already populated. There are the types of nodes. So when I say types of node, there are node labels. So there are two types of nodes we have. A label that we have is a person, and the another label that we have is movies. And the relationship types are acted in, directed in, follows, produced, reviewed, and wrote. So from this you can get a sense that we have a movies data where we have some persons. So when I say persons, the persons can be actors, directors, producers, reviewers, writers, etc. And relationships, so basically some person, some actor acted in a movie. So the acted in is a relationships, the directed is a relationships. Okay, is a relationship. Some person follows some other person, so that is a relationship. There's a producer, and the producer produced the movie, so the person producer produced a movie, so this is a relationship. And there are some property keys. So as I said, both the nodes and property, both node and relationships have properties. So there are some properties like born, data, name, nodes. Okay, title of a movie, tagline of a movie, name of a person, when the person was born, when the movie was released. So all these are properties. So this is how the Neo4j browser looks like. And you have some preloaded like play, start, and all kind of queries loaded. So this basically help you navigate further. If you want to get started with Neo4j browser and you click on get started, it takes you to a introduction guide which has some instructions to help you move around and understand more of Neo4j browser. So you see browser editor, and all these things are explained over here. So what is a result frame? This is a text area where you write your queries, and this is a button using which you execute your queries. If you have a lengthy query which spans in multiple lines, so you press shift enter and it expand this to multiple rows. And for executing the query, you basically press control enter or click on this button, and this is the result area where the results will appear. So these are some instructions that you can get from here. I'll just close this, and I'll go to my workshop. So as I explained, the movies database is preloaded, and we'll hit some queries so that you will get an idea how to load data into Neo4j database and how to read data from Neo4j database. Okay, so here you see the workshop steps. So I have created some set of queries.
Uh, just a suggestion, maybe can you zoom in the browser a bit so that it becomes a little readable?
Yeah, definitely. Let me. Is it better now?
A bit, but not much. Just
Okay.
yeah, this is better.
Okay. This is also 150% now. Okay.
Yeah, this is better. Yeah.
Okay, so we have some queries, as I said, creating a person with name John Doe. Okay, so I'll not talk about the constraints and indexes and all. They are also some building blocks. So there are some things which are required to define schema. Okay, if you want to enforce some schema constraints, you can use constraint, but I'll not talk more on it because we are having a basic session. But yeah, if you have constraints defined, then basically you can have some conditions like if you want to allow a person with same name or not, these kind of things. But I'll not talk about it right now. For that, I'll share some documentation information at the end of my presentation. So here I'm creating a person with a name John Doe and who was born in 1990. So I'll just take this query. I'll go to the Neo4j browser and I'll execute. So here you see I am labeling a node. So this is how I create a node. This is the parenthesis, the round braces I use for creating a node. I label the node as a person, and this is how I use a label. So it is colon and then person, the label name. And then inside the curly braces, I have the name property, which has John Doe, and the born property, which is 1990. And when I execute it, it says added one label, created one node, set two properties. So added one node. This is the whole thing I am doing here. This is a node. This is a label, and these two are properties. So it created my person John Doe with two properties. Now let's see how I want to query this John Doe. So I would see in case of SQL you would use select instead of select. In Cipher you have match. So you use match and then you again define the same kind of ASCII pattern with this round braces, and you will see a person label, and you are giving a variable here. So as I described in one of my previous slides, you can attach a variable to a node or a label. Okay. So P person with name John Doe. So this is basically a condition. In SQL, you have where condition, right? So instead of where, you can define it in this way also in Neo4j. So this is a JSON-like format where you see name equal to John Doe, and then you say return P. So it will basically return a person node, and this is a visual representation. Okay. In graphs, the entities are represented as nodes. So here you see it is represented as nodes. Now, if you want to see the tabular representation, you might be thinking that, hey, I'm building an application where I'll be using some data of these entities. Okay, so how would I know, how do I get the result in form of some readable application readable data? So I'll come to that part in further queries. Before that, I'm attaching this person to a movie. So I'm matching a movie with name matrix. So as I said, there are some preloaded data. So the matrix movie is already loaded when I created the database. I created a person with name John Doe. So now I'll do create a pattern where I'll say person P has acted in this movie M. M is a movie, M is a variable, and acted in is a relationship type. And then in the acted in relationship, I'll just press an enter over here to make it more readable. So in the acted in relationship, you see there's a property of roles. So what all roles the person had. So in movie, let's say Tom Cruise acts in a movie Mission Impossible. So what is the name of the person? What is the name of Tom Cruise's character in movie? Okay, so this is what the role is. So what role the person played? So for example, I have said himself, or I'll say some name like uh, in the movie the name of the person was John only. So he acted as the same with the same name. So when I execute this query, you will see it will create a relationship between John Doe. It will call the relationship type as acted in, and it says roles equal to John. Okay, and it attaches the node with this the matrix movie. So this is how the node is connected to another node with a relationship. There is a simpler syntax as well, like uh, here instead of create, I would say create, and then I'll simply say person, and then I'll say acted in, and then movie, and uh, I'll change this movie to be something else. So let's say, okay, I'll keep matrix reloaded. Okay, I think there's some error. Say create. Okay, I think I'm making some mistake. Okay, so let me skip this because it's already I'm taking already more time than what I expected. So I'll add that query in my documentation when I share it with you guys. Okay. Now I'll see. I'll go to a next query where I'll say John Doe and the movies in which he acted in. So I'll say this match person with name John Doe and go to relationship. So acted in movie and return me P, A, and M. So I have given variable to person, relationship, and movie as well, and I'm returning this. So you'll see it is returning me the same result that that got returned to us when we created this pattern. Okay, so John Doe acted in this movie. Now, how to delete data? So if I want to delete the person John Doe from the database, so I'll say match the person first. So select the person first and then delete the person. And before deleting the person, we also need to delete the relationships. So while we are deleting the John Doe, we must also delete the acted in relationship. Otherwise, it will stay hanging. So I'll say detach and then delete. So it will delete the John Doe person and then it will delete this relationship as well. Now if I copy this query and run it again, you will see it will not return any results. So this is how a person is deleted. Now I'll find one more person, like finding a name person with name Tom Hanks. So this is how it is found. And as I said, in case of SQL, there's a where condition. So in Neo4j, we have multiple ways in which you can describe this condition. So in this bracket, you can also have a where condition like P person, P name, Tom Hanks, and then return. And then here it goes like this also, like match P person where inside the uh, round braces only you define your where condition and return P. And these all queries are same. So basically, if you want to see if these queries are same or not, there are some profile commands also in like in other database we have the profile command where you can execute the profile command and you can see how costly how is the execution plan of the query and how costly the query is. So similarly you have this profile commands in Neo4j, and you if you can go through these queries and you can execute these queries with profile, and you will see all the queries are running with the same cost. Okay. Now as I talked about in while executing the first query, that how do I get the results in form of application readable data. Okay, so initially if you see in this query I was returning the whole label. So I was saying that hey, match the person with name P and then return me the label P itself, the whole label. Instead of label you can also return the properties. So here I'm saying person P, name Tom Hanks, acted in movie, and return me the P dot name, x dot roles, and m dot title. So in this case, it will return me a tabular format result like Tom Hanks acted in Apollo 13 with a role Jim Lovell. Okay, so this is how the table specific results is written. And basically, you store your data in a graphical way, and in your application, you read it in this fashion so that you can basically display it in some other UI that you have for your application. Okay, so this is how it is written. Now there are some other queries, interesting queries like fetching counts and all. So Tom Hanks acted in movies. So how many movies Tom Hanks acted in? So there's a count query. So there's a count query. Fetching all directors. So right now we use the acted in query. Instead of that, we use the relationship type directed, and I get all the persons with directed relationships. So all if I want to know the names of all the directors, then I use director relationships and I keep this open ended. Say any movies which they directed, just give me the names of the directors. So it will give you the director names. Now you see there are some repetitions. Okay, so for that you have a distinct clause as well. So you distinct it and then it gives you the distinct set of records like Lily, Lana, Taylor, James. The distinct records are written. Okay, there is some more conditions like only written if the directed relationship exists. So don't return me all the persons, just filter on this director relationship and return me the director name. So this is also how you can write it. Now there are some more queries. I'll not go through all the queries because of the time constraint, but yeah, uh, in case of Neo4j for aggregation also we have some queries. We have some words like collect and count. So you see matrix movie acted in person, so the person who acted in matrix, so I want to get the cast of matrix. Okay, so you see it is all grouped together, matrix all the people who acted in movie, and basically the size of the cast, how many people acted in Matrix movie. So I'm taking a count, I'm taking a collect of all the p as in the persons, and then returning the count and the grouped the collection of cast. Okay, now similar to SQL, we have in SQL, basically you have right and left join for optional matches. Okay, in case of Neo4j, we have an optional match that is available. So if a person has acted in a movie and a person has also directed a movie, so basically you want to know the names of person who has acted and directed movies. Okay, so instead in this case, there might be some people who has acted, and there might be some people who have directed, and there might be some people who have done both acted and directed. So you use optional match to match the actors, you use optional match to match the directors, and then you execute the query. So it will give you, okay, Keanu Reeves, he acted in 7 movies, he directed 0 movies. But there are some people who have both, like James Marshall, he acted in 1 movie and he directed 2 movies. Okay, so this is how you use the optional match. And there are some more features like pattern comprehension. So while returning the results, you can use the pattern so that you can save on the cost of the query and all. There are some other queries where you can you can take more nodes into picture, more relationships into picture, and then you can use something like, hey, who can who can act with Tom. So Tom Hanks is an actor. Okay, so if you want to find that, hey, Tom Hanks has acted with some other actors, but let me find out who all have who all actors are there with whom Tom has not acted so far. So let's introduce Tom with some new set of actors. So in that case, you basically write a little complex query, and you execute it like this, that, hey, with Tom, these guys are the ones who have not acted with Tom Hanks so far. And if Tom wants to act with them, who are the people who can introduce Tom with those guys? So Kevin Bacon and Greg and Helen, they can introduce Tom with Jack, and then Tom can act with them. So this is how you can basically write some complicated complex queries. Okay, so this is how the hands-on part is. Now, before moving on to the next topic, that is Neo4j importer, I would like to ask Sid. Sid, do we have a few minutes extra, like 5 to 10 minutes extra, so I can cover these topics up, or I'll just go through how these tools work?
Yeah, we have some time, and in fact, there are some questions around the data importing part also. So it would
Okay,
be good to cover up this section.
okay. So I'll take a few minutes extra. Just give me 1 minute. Okay, sorry. I just had to notify the other meeting people. So let me talk about the Neo4j data importer. So Neo4j data importer is an easy interface that provides a switcher to load data from flat files. So I'll run through an example for Neo4j data importer. So Neo4j data importer, it looks like this. So I'll just go to my browser again, and I'll close this Neo4j browser window, and I'll also close this workshop. And if you see this Neo4j instances screen, so in this you see an import button. So when you click on the import button, you will see again a window like this. And in this window, you get your password of the Neo4j, you paste it, and then you say connect, and it will connect you to this. Okay. Now I'll just remove this, and I'll start from the beginning. So how to import data in Neo4j data importer. So here in the database, we saw that there's a person label, there's a movie label, and there's a relationship that connects a person to a movie. The relationship type can be acted in, directed, produced, etc. So we can add a node of type, and we can say person, adding another node of another type, that is movie. And this is how you design your graph data model, and you connect this person with this node using a relationship, and you say acted in. Yeah, in here you see the type where I specified acted in. Okay. Now I want to load the data into this design. I just created a data model from my graph, and then I created nodes relationships. Now I'll just add the files from which I want to add the data. Okay. So I'll go to the file, and then I'll select these three files. So I have prepared these files. I'll just open one of the file for you to show how the file looks like. So here you see I have some actors and their born information, in which year they were born. Okay. And in the relationship file, there's an acted in file. I'll just open in Notepad++ to show you how the CSV looks like. So this is a CSV, and the person name and the movie. So you see Ram Charan acted in the movie RRR. So it is split by a comma. So this is a CSV file where we have person and movie names. And there is a file where I have the movie information, which has the movie names, I mean movie title and movie description, and the in which year the movie was released. So I'll just select these files and I'll say open. So you see these files populated over here. Now I'll go on the right hand side panel. I select the person. Here you see person label. Now I'll see the file listed in this drop down. So I'll select the person file from here, and I'll go to the file mapping, and here you see nothing mapped right now. I'll say select from file, and I'll see the the file columns appearing over here. So name is one of the column, born is one of the column, and you see I have mapped the columns of the files with the properties of the person node. Now the properties are in small case. So I'll just correct the name of the properties, name and born. Okay, so born is, you see, integer, and name is a string. Now if you go over here, you see the file mapping. So name property is mapped with the name column in the file, and born property is mapped with the born column in the file. Similarly, I'll select the movies file. I'll go to select from file. I'll say release tagline title and confirm, and I'll just change it to released tagline and title. And you see here it's released tagline and title. They are mapped with the column names, which are in caps. The property names are in small. Now I'll go to the acted in relationship. I'll say, okay, I want to populate the data for the relationship from the acted in file. And here you see it shows from which node to which node you want to extend this property. I extend this relationship. So you see person to movie. So in person, uh, you select this, and in movie you select this. So in file, in this acted in file, basically you have two columns. The one column is cap person in caps, and the other column name is movie in caps. So for person node, I want to map the column person. For movie node, I want to map the column movie. And then I'll say select from file. So I can also select this from file. Okay. Now what I'll do is I'll just okay, here I just missed one thing. So I need to select an ID property for this node. So for person, the identifier is a name. So I select the ID property here, and you see it is check marked. The acted in property, we have defined the start and end point. It is check marked. For movie, also I select that ID property. So ID is basically a title. we are identifying the movie with a title. There can be some ID column which you can add, but right now I have identified it with a title. So if I select it, you see it is populated. Okay, and in this, basically, I click on the preview, so it will produce a preview for me. So using the data that you added, this is how the data will be generated. So there are two movies. The first movie is Bahubali, and there are two actors, Rana Dugabati and Prabhas, who acted in this movie. The second movie is RRR, and there are a few actors who acted in this movie. So they'll get populated when I run the import for this. Okay, so this is how you can have a preview, and then you can say run import. So it will run the import. You will see that the import has run successfully, and you will see the results, that how many nodes are created, how many actors got created, how many movies got created, and how they are linked. Okay, so this is how you run the data import inside the Neo4j data importer. Now if I go to the query window again, so I'll open the Neo4j browser, and I'll see a window like this, where I'll say, okay, match M movie, and let's say which has a title RRR and return M. So it will return me the RRR movie which we just loaded using the importer. And yeah, if you want to explore data without writing queries, I mean, explore the connections of this node. So in the browser, you can just click on this button. So you see this explore button over here. So you click on this, and it will explore. It will expand the relationships of this particular node. So this RR in this RRR movies, there are actors who acted in this movie. So Ajay Devgan, Ramcharan, NT Rama Rao Jr. and Shreya Saran. They are the actors who acted in this RRR movie. So this is the data that we loaded from this. We also loaded one more movie, but I'll just skip showing that because we have less amount of time. Okay, so this is how Neo4j data importer works. Okay, so before moving to the next tool, that is Neo4j Bloom, Sid, are there any questions which you think we should answer right now before moving further? Sid.
Yeah, Chandan.
Okay, I think yeah, Sid is coming up. Hey Sid. Yeah.
Hey, shall we take up some questions?
Yeah, we can take up some questions. We can just time box it to a couple of minutes.
Okay, sure.
Yeah.
So the first question is by Joykar. He is asking, should we use Neo4j for OLTP or OLAP, where it suits more? With small example.
Okay, OLTP or OLAP. So it depends on the requirement, right? So if you want to have some OLAP kind of requirements where you have relationships of more importance, as I said. Okay, in OLAPs basically there can be multiple cases, right? So in OLAP basically you need to produce some reports out of some transactions, and you need to do some reconciliations and all, like I mean the prices of stocks in all the every 5 minutes, and then you basically need to show some reports and all. So in those cases, basically the relational databases fits in more. But if you want to show some analysis, like, okay, I mean, what are the trending products in a particular region? So let's say talking about the e-commerce use case. So an e-commerce website is selling some materials in different areas, and in different areas people have different likings, right? So what are they purchasing over the period of some time? So if you want to produce some reports like, hey, what are the trending things in these areas? And so that's where you basically have a database or a data model where the people bought some products from different categories, and you want to produce a report like what are the categories which are trending. So in such cases the relationships are of more importance. So in those cases you use the graph database. Also in contact tracing, as I talked about the COVID example, the contact tracing, right? So if you just try to imagine the contact tracing in the tabular format, that how do you store that data in a table? Okay, so in that case, storing the data and getting the result out of the tables is a lot complex, right? I cannot just think about the query to get the data of a person who met the first contact, then the second contact, then the third contact. So in that case, the graph database is of more I mean more graph database fits in more. Okay. And in case of OLTP, so OLTP is basically where you have the in and out load. I mean, the insert updates are running more on your database. Okay. So for that, I mean, it's not a judging factor. So it Neo4j performs I mean, I would say performs way faster than other databases in these kind of operations. So I would not judge it based on the OLTP. But yeah, in while defining it based on what data you want to get out of your database, based on that you can take the decision. It does not. It is not just dependent on the OLTP and OLAP.
Got it. Hopefully, it answers what Joy is asking for. The next one is it's a bit a longer question. Sir, if you don't mind here, if we can do without any import CSV file to create some nodes and relationships and to create graphs finally. So then I
Hmm.
want to save a CSV file that entire all data with rows and columns as per an Excel file. Is it possible to do? Actually, here we have an export CSV option, but it's only created individual cipher only and graphs only. So that's why please let me know if that's possible. Did you get the question by any chance?
Yeah. Can you please bring the question up again on the screen?
Okay.
Okay. So I'll try to answer based on what I understood. Okay. So you are saying that is there any other option apart of the import CSV? Okay. So yeah. So you think of any database. So in case of any database, there are ways to ingest data into database. Okay. So you talk about, for example, I take the most used SQL Server or Oracle database. Okay. So in case of SQL Server or Oracle, what are the options to ingest data to the database? Okay. So you have some migration tools. Okay. You take data from one source and then you run some migration script and you load the data into that database. So similar to that, we have some migration tools and connectors available from for Neo4j. I'll not talk about them in detail, but in the documentations and in the Graph Academy, you'll get to know about those tools. So that's the first thing, that you need to load the initial set of data before you begin with your application. The other use case is you have an application. So let's say you are creating a website where the users will be registered from the web page. Okay. So when the users are getting registered from the web page, uh, the users will fill in the form, and that form data will move to the database and it will be saved into the table in case of SQL Server. Similarly, in case of Neo4j, when the user fills the registration page, you have the registration information of the user. You have some language, like you have built your application in Node.js or Python or .NET. So you take that data from web page to server, and then you store that data into database using the SQL Server driver, right? So in case of Neo4j also, we have a driver that you can use with any language, and you get all the data from your website and you just fire the query from your code to store the data in Neo4j. So that is how you ingest the data into Neo4j. Okay. And of course, I mean, if you want to do it manually, so you have your data in Excel and you want to generate uh, some cipher inject or create statements out of it, you can basically use some tool to, or you can use Excel concatenation to produce your cipher statements, and then you can execute those statements. But that is not a suggested way, that is not a right approach. So either you use some migration tool to migrate some data from other application to Neo4j based on what you want to use in Neo4j. So basically, first design your model, how your nodes and entities and relationships will look like. And then there's another data in some other database. For example, in Oracle, you have some tables, and from those tables you want some information to move to Neo4j. So you use the Neo4j data connector, and you query, you specify your Oracle query there. At the other end, you specify your Neo4j create cipher, and it takes the data out of Oracle, and it ingests it to the Neo4j. So that is how, I mean, these are some of the approaches that you can take.
Got it. And this is another question by the same audience, same person. That by mistake, if there's some nodes and relationships which were created and now you want to remove them, is there a way to remove them or change the names or rename it, those nodes and relationships?
Sure. So that's a good question. So basically, yeah, it happens in case of graph database. We fall into some cases when we wrongly name some of the nodes, right? Okay. So I would say it is the most easier in all the databases to change the name of a node and change the name of relationships. Okay. In other databases, let's say you create a table or a column with a different name, and you want to make a change into that column. So you have to take care of a lot of things, right? If I change this column, the foreign key will be impacted. The other table should also be changed and all. In Neo4j, it is the most easiest. Uh, so basically, you can do it with a simple set of cipher statements where you fetch the nodes, and then you select the label, and then you give it a new label, and then you remove the existing label. So there are queries that you can find on the Neo4j documentation. If not, you can contact me on my LinkedIn page, and you can just query those questions to me. I'll help you with the specifics.
Cool. Sounds good. Thanks, Chintan. I think that's pretty much. There's one more question by Siddharth, which I will take it up towards the end.
Sure. Okay. So I'll quickly move to the Neo4j Bloom. That is the third and most important tool when it comes to the Neo4j ecosystem. So I'll again go to my instances screen, and here you see we just checked the import, we just checked the query. Now the last option, that is explore. So explore is basically the graphical representation and visualization of the Neo4j database. So here also you get the same kind of a window where you need to specify the username. Username is the neo by default it is neo4j until and unless you specify something else while creating your database yourself. You again get your password from the downloaded file, and then you say login, so it will log in. So Bloom is basically uh, a tool for, I would say, non dev kind of users. Devs can also use it, but it is more useful for the non dev kind of users because it has some uh, layman, I mean, capabilities which anybody can easily understand and execute. Okay. So Bloom looks like this. So some nodes came up when I started. It was because I was using it previously, but when you launch it, it will look like this. It's a plain interface. This is a pane where you will visualize the nodes and relationships. This is where you will see the nodes and relationship types. So you see the movie node, person node, and when I click on the relationships, it shows the different relationships that we have in our graph. Okay. And this Bloom interface is basically we navigated it from here, right? So this Bloom interface is default connected to the database, the Neo4j database that we have. Okay. So here you see the movies and persons and click on relationships, and it has all the relationships. Here you click on the perspective. So perspective is basically uh, what I can say is your configuration that you have configured your nodes entities to look like this. So I have given some icons and color to this movie and person nodes. Okay. So these are some configurations that I have done myself. So I have selected some icon for the movie. So you can click on the movie node, you can say icon, and you can click any item. So you can search for it like movie, and it will show you some icons. I have selected one of the icons like this. Okay. So it appeared over here. If I click on person, I can change the color of the person node. Like let's say I make it to a little bit red. And then also, let's say I want to increase the size. I can increase the size of the person node, how the person node should look like when I return the result in this pane. Okay. There is also some rule based styling, which I'll not talk about because it will be a lot overwhelming for you in the beginning session. But yeah, this is how configurations you can set, and all this configuration that you can set over here. And also, when you click on this perspective, you have the categories which are displayed over here. So you see person and movie are displayed over here. In relationships, okay, we have all the relationships like acted in, directed in, follows, produced, reviewed, wrote, all are displayed over here. Also, there is a section called saved cipher. So I'll come to this section later. But this is how basically Bloom looks like. It has three areas. This is the results pane. This is the perspective where you see all the categories, the types of labels and nodes which are displayed over here, relationships and save cipher. This is where you configure your nodes and relationship to look in a particular fashion. Okay, now this is the search pane. So this is the search area where you basically hit some search queries, and in Bloom, The special thing about Bloom is you don't have to write ciphers. Okay, it is very handy, very easy. So when you click over here, it has some intelligent suggestions. So you see movie, person, and these are relationships. So if I click on person and if I say enter, so it will show me all the persons who are there in the graph. Right now I have limited set of persons in the graph, so it is showing all the node labels. But yeah, don't try it on a live database, on a database with a large amount of data, because it will basically show many nodes, and it has some settings like how many number of nodes you want to display when you select something like, okay, show everything. So there are some sections like settings and nodes, all, so you can explore these settings when you are exploring Bloom. So I have displayed all the persons. Now if I click here, I can extend it like, hey, a person, I also want to see the acted in relationships for that person. So what all movies the person acted in, so it will display you what all movies the person acted in. So you see this person, for example, Ethan, he acted in a movie. This this is a movie, Snow Falling on Cedars. Okay, and you can click on any of the node, you can double click on any of the node, I'll be precise, you can double click on any of the node, and you can see the details of that node. In the details of that node, it will show you the properties of that node. So if you see, in case of this Harris actor, we have the name property, we don't have the bond property. And you can also see the neighbors, like this actor is related to this movie. Okay, so this actor acted in this movie, so it shows that it has a movie which is Ninja Assassin, and the movie details. And then again, relationship, so actor is having acted in relationship with one of the movies. So all these details are visible over here. When you click on, let's say, some other actor, so Tom, he is born and name, both the options. Again, neighbors, relationships. If you double click on any movie, so it will show you the movie details. So this is how you expand the details of a node. Okay, and this is as I said, this is helpful to non-dev people who are not technical but still want to go ahead with some demonstrations, some presentations with Neo4j database. So this is how easy it is for you. I can further extend it like actor acted in movie, and then in that movie there may be some other actors. Okay, so in that movie there are some other actors who acted in. So I'll just close. So it is like a person who has acted in a movie, and in the same movie there can be some other actors. Okay, so before executing, before pressing enter, I'll just go here and I'll just say clear scene. So it will clear the existing output, and I'll say enter. So here you will see that it will show me the whole graph, like this actor acted in this movie, and in this movie some other actor also acted. So it is all connected. So it shows us the connected graph in this pattern. So this is how you can navigate through the entities and relationships using the pattern, and this is without writing cipher and non technical. Okay, now I'll clear the scene. I'll show some other useful feature. So as I said, there is a saved cipher feature. So if you want to go a little advanced in your presentation and you want to demonstrate some natural language processing kind of a features, that hey, if I type something in a natural language, and then if I want to execute some query in background and produce some results out of it, so you have a saved cipher kind of a feature over here where you see search phrases. So I have created a search phrase. I can click on the add search phrase and add a phrase details. I have already created a phrase which I'll just go through. So recommendations for actor. Okay, so recommendations for actor with a particular name. So you see this is parameterized. So you expect this information to come out from user, and then you execute this query that hey, can I recommend some co-actors to this actor? So, for example, Tom Hanks has acted in few movies, and he has acted with some set of people. So, he has acted with some co-actors. Now, I want to suggest some actors with whom he has not acted before. So, this is a query where I have this parameter, and then this is a data type. This is a label, that what label do I need to suggest. So these are some configurations, said that hey, I want to have suggestions from the label key from person, and I want to have the data type of that variable, the parameter is string. And then when I say recommendations for the actor, and it will give me some recommendations. That, hey, give me recommendations for, let's say, Tom Hanks. That who all actors Tom Hanks have not acted with so far. So it gives me the actors with whom Tom Hanks has not acted so far. So these are the actors Tom Hanks can act with, so that he can increase his network. Okay. So this is how the search phrase saved cipher works with Neo4j Bloom. So this is how Neo4j Bloom works. Now, I have also mentioned these features in my deck, which I'll not talk. But quickly talking about the whole Neo4j data platform. So we discussed about the three tools: the browser, the importer, and Bloom. There are many other applications and tools in the Neo4j ecosystem. So in the center you see the Neo4j database. Okay, and it has many features for any kind of audience. So for different kind of audience, Neo4j ecosystem has different tools. For example, there are tools for database admins and developers. There are tools for application developers. We have drivers, we have some libraries for different programming languages. We have discovery and visualization. So like we saw the Neo4j Bloom, so it is for discovery and visualization for the business users. We have some analytics tools, again Bloom, and some dashboard tools that we have, which are easily integrated with Neo4j, and data analyst and data scientists can use them. Okay, so this is how the Neo4j graph database ecosystem is. As I talked in my previous while answering one of the questions, so we have language drivers available. So while connecting to any other databases, you have your language drivers. Like for SQL Server, you have Microsoft SQL Server driver. For Postgres, you have the NPGSQL driver. Okay, so similarly, Neo4j has drivers available for various languages and almost all the languages: Java, JavaScript, .NET, Python, Go, and we have some official drivers, and we also have a large community. And when I say community, there are people who have developed some other drivers for some rare languages also. So you have some community drivers also available. So here you see all the checkmarked drivers, the languages where we have checkmark, we have all official drivers available. And for these languages like Ruby, PHP, Erlang, Perl, for these kind of languages we have community drivers available, but they are also mature in nature, so you can easily use them with your application for your application development. Okay, as I said, we have some connectors and APIs like Kafka connectors, Spark connectors, JDBC drivers, BI connector, data warehouse connector, Spring, and we also have some OGM tools. Like in case of I'll talk about SQL Server again, because I come from Microsoft Tech Stack. So in SQL Server, we have the entity framework, which generates the basically the object model for the data that we have in SQL Server. So in case of graph database, we have object graph model. Okay, so we have Neo4j OGM that is available with Neo4j Spring Data Neo4j. We also have a very useful and easy library available with Neo4j for GraphQL and Node.js. So JavaScript library with GraphQL is very easy to use and integrate with your application. Okay, so there are such libraries. We have some extensions as well to execute some complex queries. Like in other databases, we write procedures. So in Neo4j also we can write procedures. We have a default inbuilt set of procedures, what we call APAC, that is called awesome procedures over Cipher. We have a tool called Neo Semantics, which gives you the RDF integration, the resource definition language kind of a object model if you want to create. There is a Neo4j Streams, which provides you Kafka integration, and we have a graph data science library which you can use to conduct graph data science. And graph data science is altogether a different topic. I'll not talk about it more here, but it's a very useful library, and you can consider it if you want to have some graph data science and machine learning and AI capabilities in your application. There are visualization tools. We talked about Neo4j Bloom. There is also a Neo Dash. There's a tool available with Neo4j which we call Neo Dash. It is developed by one of our my ex Neo4j colleague, and it is a very useful tool if you want to create some dashboard out of Neo4j with low code, or basically low or no code. So Neo Dash is one of the tools. There are some dev tools which are like Neo4j Aura, desktop browser importer. So we talked about desktop browser and import. We talked about browser and importer. Database, Neo4j desktop is like you install it in your desktop, in Windows desktop, and then you don't need to go to the browser to access the Neo4j. So that's Neo4j browser. Okay, so that was pretty much all from my side. I took a lot more time than we expected, but I hope I covered everything. And yeah, how do I continue my journey with Neo4j? So I think Siddharth, do you have some information on this, or should I cover it?
Yes, I'll be talking about it.
Okay,
Uh, just before that, maybe you want to take up this question. This is the last question out here. Can we integrate Bloom as a plugin with any JavaScript and get the same node visualization in the UI of an application?
this is a very good question, and
Yeah.
I'm glad that this question is coming up in our first session. So Mahesh, thank you for asking this question. And yeah, so Bloom basically is a web interface, right? And when you have some application in some other language like React, Angular, or some other framework, right? And as you said, you want to integrate the Bloom visualization in your application's UI. So we have a feature called Bloom embedding. Okay, so the Bloom embedding is in technicalities it is called deep linking. So there's a feature called Bloom deep linking. So in your UI, you can have an element which has an iframe. Okay, so you can have an iframe inside your HTML page in your framework. So in Angular, you have an iframe component, and then you provide the Bloom URL to that iframe component. And inside that Bloom URL, there is a provision that you can also give some URL query string parameters, like what query you want to execute when the Bloom opens up. Okay, so by default, when Bloom opens up, it is a plain area. It does not show any results. But let's say the user on your UI page clicks on a button. Say for example, I have a movie page, and I want to have a detail of the movie, that when the user clicks on the movie, I want to show the cast. Okay, so I want to execute a query that, hey, show me the cast of this movie when the Bloom opens up. So you save a cipher inside the saved cipher section of the Bloom, as I described in my demo, and then you specify that cipher name with the parameter, the movie name, in your query string which you pass to the iframe, and it opens a Bloom, and it automatically runs that query where you see the Bloom results. Okay, and I have an example of such in one of my GitHub repos. Probably I'll share that repo URL with Sid. So
Yeah.
I have created an example with deep linking, which you can explore.
Super. Thank you. Thanks, Chintan. Well, before we wrap it up, just few quick things. Yes, there was a question as well from one of the attendees that where can I learn more about Neo4j and how do I continue my graph journey forward? The best way is to go to Graph Academy. We have made these amazing free self-paced hands-on online courses that you can check out on graphacademy.neo4j.com. And what's more, once you complete these courses, you can also go for a certification. We have two certifications. These are completely free certifications: Neo4j Graph Data Science certification and Neo4j Certified Professional. So complete the two certifications, and yes, you will get a T-shirt as well at your doorstep. Okay. Next, I want to talk about Nodes 2023. Super excited to inform that Nodes is back. For those of you who don't know, we did this last year as well. We did a 24-hour marathon of graph content, starting in Americas, ending in EMEA, where continuously we were talking about graphs and Neo4j. And we are excited to bring this back again this year, happening on 26th of October. So if you wish to attend, you're a beginner, you're intermediate, you're in advanced stage, no matter wherever which stage you are in, you can attend nodes, and we have content for all of this, all of the categories. If you want to submit your talk, we are encouraging folks to submit their talks as well. So go to this URL dev.neo4j.com/nodes23, and you can submit your talks. The deadline is June 30th. And if you wish to get connected with the passionate graphistas, you can join the graph database user groups. We have, I guess, 40 plus user groups across the globe. The URL is meetup.com/pro/neo4j, and you can find groups across the regions, and wherever, uh, whichever group is like closely available for you, you can go in over there, join the meetup group, and stay connected with us. Whenever we do any of the meetups, be it online or be it offline, we post it on those user groups. If you wish to speak at any of these meetups, again, online or offline, you can submit your talk. That's the URL dev.neo4j.com/summit-your-talk. Okay. What's next? The last two things. One is on the Neo4j Ninja program. Chintan is well a Neo4j Ninja. He was part of Neo4j earlier, and then once he moved out of Neo4j, we made him a ninja because he's really, really passionate about Neo4j and graphs. And we are looking for more passionate individuals like you. If you feel that you are an expert in graphs, you have been doing active graph blogging, presenting content, or doing GitHub contributions, anything, just reach out to us. That's the URL bit.ly/ neo4j ninjas. Make sure the capital ends out there in the URL because it's a case sensitive URL. And the last thing is, if you wish to stay connected, I believe we were not able to answer some of the questions over here. But if you have more questions on this content, anything else other than this, anything around Neo4j, we have two platforms. One is our Discord's uh, platform, and another one is our Discord handle. So you can post it on any of the places. The dev.neo4j.com/community will take you to our community website, and dev.neo4j.com/chat will take you to our Discord handle. With this, I'd like to thank Chindan once again for giving his precious time. Before Chintan, I'll give you talk just a quick reminder about the next two sessions. Session number two, which is happening on intermediate cipher and data modeling, which is happening next week on June 1st at 2 p.m. IST. Make sure you register for it. All the link for the registration is available in the meetup groups. You can find any of the meetup groups and you'll find the link over there. And we're doing another one in the third session in the series called Knowledge Graphs with ChatGPT. This is going to be really, really exciting one. I'm looking forward to this, which is happening on June 14th at 10 a.m. IST. With this, yes, we wrap up the session. And Chintan, any last words, any thoughts, anything like to talk about?
Yeah, so I actually just wanted to show the query which we ran into error. So if you can just bring my screen again, the presentation. Okay, so there was a small mistake which I made. So as we were discussing that if we created a person with name John Doe, and there was already existing movie with Matrix, and then we wanted to create a relationship between that person and the movie. Okay, so uh, you can just match the person and the movie. So M is the movie, P is the person, and then here you can use either create or merge. So create basically creates a relationship between P and M with acted in type. When you use merge, merge is basically an absurd statement, so it does not error out when when you already have a relationship. Okay, so if you already have a relationship and you use create, it errors out. Otherwise, if you just want to ignore this, you use merge and then you execute this. So it will basically create a relationship between John Doe and Matrix, and it will basically show it up. So this is the easiest way. Initially I showed you a query with pattern matching and pattern, but this is how you can easily create a relationship between two nodes. So yeah, that's just I wanted to show. Thanks, Sid. And thank you so much
Awesome.
for providing this opportunity. And thank you so much to everyone who attended this and spent this time together with us.
Thank you. Thanks, Chintan. And thanks a lot to everyone out there who are listening to us and stayed this till this long. All the slides will be available on the GitHub repo, which Chintan is going to share with us, and we'll update that GitHub repo in the YouTube description. This recording, this session will also be available on YouTube, so you can check us out anytime in future. All right. So this brings us to the end, and we'll see you in the next session on June 1st. Till then, stay safe. Bye.